we have integral of irrational function. So first I will rewrite our square root to power form. So this is equal integral of 3x plus 2 to power 1/2 with respect to x. Now, because we have in the exponent, in denominator 2, it means we have to substitute 3x plus 2 by u, and u we have to take to second power. Now we have to find the derivative of both sides of our equation. So it will be 3 is equal to u du to dx. Next, I will multiply both sides by dx to reduce the numerator. We have 3 dx is equal to u du. Now we have to look in our integrand. We don't have 3 dx. It means I have to divide both sides by 3. 3 and 3 we can reduce, and we have that dx is equal 2 over 3 u du. Now we can rewrite our integral, and we will have for 3x plus 2 we will put u square, and we have here power 1/2. dx is equal 2 over 3 u du. So this is equal 2 and 2 we can reduce, and 2 over 3 we will put before integral symbol. So we have 2 over 3 integral of u times u du. So this is equal 2 over 3 integral of u square du. So this is equal integral of power function formula we have to use. So we have to copy constant, and we have in numerator u to power 2 plus 1 is 3 over 3 plus constant c. So this is equal 2 over 9 u cube plus c. Now we have to come back to our substitution. We have that 3x plus 2 is equal u square. So it means that u is equal square root of 3x plus 2. So now we have to substitute u by square root of 3x plus 2. So 2 over 9 we have to copy, and we have square root of 3x plus 2 to third power plus constant c. This is equal, we can rewrite this, that this is 2 over 9 square root of 3x plus 2 to third power plus constant c. What else I should add? Because we have integral of square root of 3x plus 2, so whatever is under square root must be greater than or equal 0. So we should put that 3x plus 2 is greater than or equal 0. We have to solve this inequality. So x is greater than or equals negative 2 over 3. So this is my solution. We have integral of irrational function. First, I will rewrite our cube root to power form. So this is equal integral of x times x plus 4 to power 1/3 with respect to x. Next, because we have here x plus 4 to power 1 over 3, we will substitute x plus 4 by u to power 3rd. Next, we have to find derivative of both sides of our equation. So we have 1 is equal 3u squared du to dx. Next, I will multiply both sides by dx to reduce the numerator. So we have 1 dx, I can write it, this is dx is equal 3u squared du. Now we have to look to our integrand. We have x times x plus 4. X plus 4 we will substitute by u to third power, and we need to find x. Because x plus 4 is equal u to third power, so we can write that x is equal u to third power minus 4. So we have integral of x is u cubed minus 4 times we have x plus 4 is u cubed to power 1/3 dx is equal 3u squared du. So this is equal 3 and 3 we can reduce. So we have integral of u cubed minus 4 times we have u times u square, so will be u cubed, and 3 we can put before integral symbol du. So this is equal. Next we will do multiplication. 3 times integral of, and in parentheses we will have u cubed times u cubed is u to power 6. And next we have minus 4u cubed with respect to u. So this is equal. Integral of difference is equal difference of integrals. So we can rewrite this, that this is equal 3 times, in brackets we will put integral of u to power 6 with respect to u minus integral of 4u cubed with respect to u. So this is equal. We have to copy 3, and integral of power function formula we have to use. So in brackets we will have u to power 6 plus 1 is 7 over 7 plus constant. We will put constant at the end. So next we have negative sign. 4 I will put before integral. So we have integral of u to third power. Again we will use integral of power function formula. So it will be u to power 3 plus 1 is 4 over 4 plus constant. I will put this at the end plus c. So this is equal. Now we can do multiplication. We have 3 times u to 7 power over 7, so will be 3 over 7 times u to power 7 minus 4, and 4 we can reduce, so we have 3u to power 4 plus constant c. So this is equal. Next, because we substitute x plus 4 is equal u to third power, so I will rewrite our u to 7 power and u to 4 power. 3 over 7 we will copy, and I will put that u to 7 power, this is u to third times u to third power times u. When we have the same base, we just add exponent. If we don't have, it means this is invisible 1. So we have 3 plus 1, this is 7, minus, and we have u to fourth power, so it will be u to third power times u to first power, plus constant c. So this is equal. Next, I will factorize 3 over 7 and u. So in parentheses, we will have u to third power times u to third power minus 7u to third power and we have plus c. So this is equal. We will copy 3/7 and u we will substitute. We know that x plus 4 is equal u to third power. So it means that u is equal cube root of x plus 4. So now for u we will put cube root of x plus 4, and in parentheses we will have u to third power is x plus 4. So we have x plus 4 times x plus 4. So I can put square minus 7 times u to third power. So we have this. This is equal x plus 4. So we have plus c. This is equal 3/7 cube root of x plus 4 we will rewrite, and in parentheses we will have x plus 4 to second power is equal x squared plus 8x plus 16, and we have negative 7 times x is negative 7x, negative 7 times 4 is negative 28, plus constant c. So this is equal. We have to copy 3/7 cube root of x plus 4, and in parentheses we will have x squared, 8x minus 7x will be plus x, 16 minus 28, so we have minus 12, plus constant c. This is my solution. We have integral of irrational function. So first, because we have here square root in denominator, we cannot have 0 in denominator, and whatever is under square root must be positive. So we have that 5 plus 4x must be greater than 0. So x must be greater than negative 5/4. Next, I will change the square root to power form. So this is equal. We have integral of, because we have square root in denominator, so we will have 5 plus 4x to power negative, and square root, so we have power 1/2 dx. Next, to solve this integral we will use substitution method. Because we have 5 plus 4x to power 1/2, so we need to substitute 5 plus 4x by t to second power. We have to always check denominator of our exponent. And to reduce this exponent, we need to put substitution to the same power which we have here in denominator. So now we have to find derivative of both sides of our equation. It will be 4 is equal to t dt to dx. Next, I will multiply both sides by dx to reduce the numerator. So we have that 4 dx is equal to t dt. Next, because we have only dx here, I will divide both sides by 4. 4 and 4 we can reduce, and 2 with 4 will be 2. And we have that dx is equal 1/2 t dt. Next, we can substitute to our integrand. We will copy symbol of integration, and we have 5 plus 4x is t squared. So we have t squared in parentheses to power negative 1/2, and dx is 1/2 t dt. Now we can reduce. When we have power to power, we do multiplication. So 2 and 2 we can reduce, and we can put 1/2 before integral symbol. So this is equal 1/2 integral of t to power -1 times this t dt. So this is equal 1/2 integral of, and when we don't have power is always invisible 1. When we have the same base, we add exponents. So we will have t to power -1 plus 1 is 0 dt. So this is equal 1/2 integral t to 0 power is 1 dt. So this is equal integral of 1 is with respect to t is t. So we have 1/2 t plus constant c. Now we have to come back to our substitution. We put that 5 plus 4x is equal t squared. It means t is equal square root of 5 plus 4x. So now we will substitute t, and we will have 1/2 square root of 5 plus 4x plus constant c. This is my solution. We have integral of irrational function. So first, because we have in denominator 2x minus 1, we cannot have 0 in denominator, so x must be different than 1/2. What else? We have fifth root. We can calculate fifth root of all real numbers. So next we will rewrite our fifth root to power 4, and because we have this expression in denominator, we need to put 2x minus 1 to power, first we have to power 3, and next, because this is in denominator, we need to put to power negative and fifth root, so we have to power 1/5 with respect to x. Next, we can rewrite that this is equal integral of 2x minus 1 to power -3/5. When we have power to power, we have to multiply exponents. So with respect to x. So this is equal. Next we will do substitution. 2x minus 1 is equal, because we have in denominator in our exponent 5, so I will put t to power 5 to reduce this fraction. Now we have to find derivative of both sides of our equation with respect to x. So we have 2 is equal 5t to 4th power dt to dx. Now I will multiply both sides by dx to reduce denominator. So we have that 2 dx is equal 5t to power 4 dt. Because we have only dx, so now I will divide both sides by 2. 2 and 2 we can reduce, and we have that dx is equal 5/2 t to 4th power dt. So now we will rewrite our integral. This is equal, we have 2x minus 1 equals t to power 5th, and we have to power -3/5. dx is 5/2 t to 4th power dt. So this is equal 5 and 5 we can reduce. 5/2 we will put before integral symbol, and we will have now t to power -3 times t to power 4 dt. So this is equal 5/2 integral of t to power, when we have the same base we add exponent, so it will be 1, we don't have to write, dt So this is equal 5 over 2 integral of t is t square over 2 plus constant c. So this is equal 5 over 4 t square plus c. Now we have to come back to our substitution. We have that 2x minus 1 is equal t to 5th power. It means that t is equal 5th root of 2x minus 1. So this is equal, we have 5 over 4, and now we will put 5th root of 2x minus 1, we have 2 second power plus constant c. We can rewrite this. It will be 5 over 4 5th root of 2x minus 1 to second power plus constant c. This is my solution. We have integral of irrational function. First, I will change this cube root to power form. So this is equal integral of x times 3x plus 1 to power 1/3 dx. Next, we will do substitution method. I will put that 3x plus 1 is equal t. Because we have in denominator in our exponent 3, I have to put t to power 3rd to reduce this exponent. Next, because we need to substitute 3x plus 1 and we have to substitute x because we cannot mix up x and t in one expression. So now I will find from this equation x, I will move positive 1 to the right side. So we will have that 3x is equal t cubed minus 1. Now I will divide both sides by 3. 3 and 3 will reduce, and we have that x is equal t cubed minus 1 over 3. Now, when we use substitution method, we have to substitute dx, so we have to find dt. It means we have to find derivative of both sides of our equation with respect to x. So 3 is equal 3t squared dt to dx. Now we multiply both sides by dx to reduce the numerator, and we have 3 dx is equal 3t squared dt. Because we have here only dx, I will divide both sides now by 3, and we can reduce 3 and 3 on the left side, and we have that dx is equal 3 and 3 on the right 2. So we have t squared dt. Next, we can rewrite our integral, and we will have integral. For x, we will put t cubed minus 1 over 3. Next, we have 3x plus 1. This is 3 cubed. We have to power 1/3. We have to copy. And the dx is t squared dt. So this is equal. We can reduce 3 and 3. We have here division by 3, so we can take this. It's like 1/3 before integral symbol, and we have integral of, I will put this t cubed minus 1 in parentheses. And next we have t to first power only times t squared is t cubed dt. So this is equal 1/3, we have copy, and we have to do multiplication. T cubed times t cubed will be t to 6th power minus t cubed times 1 is t cubed dt. We have integral of difference, so this is equal difference of integrals. 1/3 we have to copy, and we have integral of, in parentheses, t to 6 power with respect to t minus integral of t to third power with respect to t. This is equal. Now we have to use integration of power function formula. 1/3 we have to copy, and in brackets we will have t to 6, so will be t to power 7 over 7 plus constant. I will put at the end because constant plus constant is still constant. And we have minus t to power 4 over 4 plus c. So this is equal. Next we can factorize because we have in denominator 7, and so I will write that this is equal 1/3 times 1 over 28 to reduce these denominators. And in brackets, what else? Because we have t to 7 power, and we did substitution that t cube is equal 3x plus 1. So I will rewrite t to 7th power, but this is t cube times t cube times t to first power. We don't have to write minus, and because I factorized 1 over 28, I have to multiply this by 4. I will put this at the beginning. And we will have 7 times t cube times t plus constant c. So this is equal. We have 1/3 times 1 over 28, and in brackets we will have 4, and for t cube we will put that this is equal 3x plus 1. So we have 3x plus 1, and again we have t cube, so I will put 3x plus 1 to second power. And now we have to substitute t, because 3x plus 1 is equal t cube, so t, let me write this here, t is equal cube root of 3x plus 1. So we have times cube root of 3x plus 1. And we have minus 7. And now we, for 3 to third power, we'll put 3x plus 1. And we have t, so we have cube root of 3x plus 1. Plus close brackets, and we have plus c. So this is equal. We can factorize cube root of 3x plus 1. So we will have 1/3 times 1 over 28 times cube root of 3x plus 1, and in brackets we have 4 times 3x plus 1 to second power. So 4 we copy, and we will take 3x plus 1 to second power, so it will be 9x squared plus 6x plus 1 minus, and because we took this cube root before brackets, so we have only 7 times 3x plus 1, so it will be, we have negative sign, so it will be negative 21x and negative 7 close brackets plus c. So this is equal. We have 1/3 times 1 over 28 cube root of 3x plus 1, and in brackets we have 4 times 9x squared is 36x squared plus 24x plus 4 minus 21x and minus 7. Close bracket, we have plus c. So this is equal 1/3 times 1 over 28 cube root of 3x plus 1, and in brackets we will have 36x squared, 24x minus 21 is plus 3x, 4 minus 7 is negative 3 plus constant c. We can factorize 3 from brackets. So we have 1/3 times 1 over 28 cube root of 3x plus 1 times 3 times, and in brackets we will have 12x squared plus x minus 1 plus constant c. So this is equal 3 and 3 we can reduce, and we have 1 over 28 cube root of 3x plus 1 times 12x squared plus x minus 1 plus constant c. This is my solution. We have integral of irrational function. So first, because we have square root of x, we know that we can calculate square root of positive or equal 0 numbers. So x must be greater than or equal 0. Next, I will change this square root to power form. So we have that this is equal integral of square root of 1 plus square root of x. So x is to 1 over 2 power dx. So this is equal integral of 1 plus x to power 1/2, and we have square root to power 1/2 dx. We can rewrite this. And now, because in denominator we have 2, so we do substitution, and we will put that x is equal u squared to reduce this denominator. Now we have to find the derivative of both sides with respect to x. So 1 is equal to u du to dx. Now we multiply both sides by dx to reduce the denominator. And we have that dx is equal to u du. Next, we can substitute, let me rewrite integral symbol, and we have in parentheses 1 plus x to 1/2 power. So x is u squared. We will put to power 1/2 and everything to power 1/2. And dx is 2u du. So this is equal. We have integral of 1 plus 2 and 2 we can reduce, and we have u only to power 1/2. 2 we can take before integral symbol, and we have u du. Next, because we have still power 1 over 2, so I will do again substitution method, and we will put that 1 plus u is equal t squared. Why t squared? Because we have 2 in denominator in our exponent. Now we have to find the derivative of both sides with respect to u. So we have 1 is equal to t dt to du. We will multiply both sides by du to reduce denominator. Du and du we can reduce. And we have that du is equal to t dt. In our integrand, we have 1 plus u to substitute, and u also. So now we have to calculate u from this equation. U is equal t squared minus 1. Now we have to substitute. So this is equal. We have to copy 2. Integral of 1 plus u is t squared, and we have to power 1/2. U is t squared minus 1, and du is 2t dt. So this is equal. 2 and 2 we can reduce. 2 we will take before integral, so we have 2 times 2 is 4. And we have integral of t to first power. times t, so will be t squared, and in parentheses we have t squared minus 1 dt. So this is equal. Now we have to do multiplication. So for integral we have of t to power 4 minus t squared dt. We have integral of difference, so this is difference of integrals. So this is equal 4, we will copy, and in brackets we have integral of t to power 4 with respect to t. So we have to use power function formula, integral of power function formula. It will be t to power 4 plus 1 is 5 over 5 minus, and integral of t to second power is t to third power over 3 plus constant c. So this is equal. Because we have fraction in brackets, I will factorize 1 over 15 to reduce this denominator. So we have 4 times 1 over 15, and in brackets we will have 3 times t to fifth power minus 5 times t cube plus constant c. So this is equal 4 over 15. And now because we substitute that t squared is equal 1 plus u, so I will rewrite that this t to fifth power to form t squared times t squared times t. When we have the same base, we add exponent, and minus 5t squared times t plus constant c. So now we can substitute t squared by 1 plus u. 4 over 15 we will rewrite, and in brackets we have 3. T squared is 1 plus u. Because we have times t squared, so times 1 plus u, I can put that we have 1 plus u to second power times t is equal, because we have t squared is 1 plus u, so t will be square root of 1 plus u, of course, and we have minus 5 times t squared is 1 plus u. Let me write this, that t is equal square root of 1 plus u. Why? Because t squared is equal 1 plus u. So we have times t, so we have square root of 1 plus u, close brackets, plus constant c. We can factorize square root of 1 plus u, and because we know that u is equal, we have that u squared is equal x, so u is equal square root of x. So we will substitute u by square root of x. So we have 4 over 15. Let me rewrite this first. We have square root of 1 plus u, and in brackets we have 3 times, and in parentheses we will have 1 plus 2u plus u square minus 5 minus u, because I factorize square root of 1 plus u, and I did multiplication, plus c. So this is equal. Of course, we have 5 times 1 is 5, and 5 times u will be 5u. So this is equal. We have 4 over 15 square root of 1 plus u, and in brackets we will have 3 plus 6u plus 3u squared minus 5 minus 5u plus c. So this is equal. We have 4 over 15 square root of 1 plus u, and in brackets we have, first I will put expression with the highest power, so we have 3u squared, and we have 6u minus 5u, so it's plus u. 3 minus 5 is minus 2, plus constant c. Now we have to substitute u by square root of x, so we have 4 over 15 square root of 1 plus square root of x, and in brackets we will have 3 times u squared is x plus u is square root of x minus 2 plus constant c. This is my solution. We have integral of irrational function. Because we have x and square root in denominator, we cannot calculate square root of negative value, and we cannot have 0 in denominator. So x must be different than 0 and x must be greater than b is constant. Now we will rewrite our square root to power form. We have integral of dx over x times x minus b to 1/2 power. So now we will substitute x minus b by t to second power, because we need to reduce this exponent. So we have to find derivative of both sides with respect to x. 1 is equal to t dt to dx. Now we multiply both sides by dx to reduce the numerator. So dx and dx we can cancel, and we have dx is equal to t dt. Now, because we have here x in the denominator x minus b, we will substitute by t squared, and we have also x. So we need to find x. I will move negative b to the right side, so we have x is equal t squared plus b. So we can rewrite our integral now to form 2t dt, because dx is equal to t dt over x is t squared plus b, and we have x minus b is t squared. We have to power 1/2. So this is equal integral of 2. I will put before integral symbol, and 2 and 2 we can reduce, so we have in numerator t dt over t squared plus b times t. Now t and t we can cancel, and we have integral of 2, we will copy dt over t squared plus b. We know that integral of 1 over t squared plus 1 with respect to t is equal arc tangent of t plus constant c. So now we will substitute t, let me write this here, t we will substitute by square root of b, we can put u. So now we have to find the derivative of both sides with respect to t. So 1 is equal square root of b du to dt. I will multiply both sides by dt. So we have dt is equal square root of b du. So now we can rewrite our integral to form 2 integral of dt is equal square root of b du over, and we have t is square root of b u to second power plus b. So this is equal to integral of square root of b du over square root of b to second power, so will be b times u square plus b. This is equal. We can factorize b in denominator, and square root of b we can put before integral symbol. So we have 2 times square root of b integral of du over b times u square plus 1. So this is equal. B is constant, so we can put before integral symbol. So we have 2 square root of b over b integral, we can write 1 over u square plus 1 du. So this is equal 2 square root of b over b and integral of 1 over u square plus 1 is equal arctangent of u in this example plus constant c. U is equal, we have to find from this equation how much equals u. Let me rewrite this. We have that t is equal square root of b u. So we will divide both sides by square root of b. Square root of b we can reduce, and we have that u is equal t over square root of b. So we can rewrite that this is 2 square root of b over b arctangent, and we have t over square root of b plus constant c. T is equal, we have to find from this equation, because we know that x minus b is equal t square. It means that t is equal square root of x minus b. So let me write this here, that t is equal square root of x minus b from this equation. We can substitute t, so this is equal. We have 2 square root of b over b arctangent of square root of x minus b over square root of b plus constant c. So we can rewrite this. This is equal to square root of b over b arctangent of, and we can write that we have square root of x minus b over b plus constant c. This is my solution. First, because we have x minus 1 in denominator, so x must be different than 1, and we calculate square root of positive or equal 0 numbers, so x must be greater than or equal 0. Next, we will change square root to power form. So this is equal integral of x to power 1/2 over x minus 1 with respect to x. We will substitute x by t square. We always put the power the same which we have here in denominator, the same number. So next, we have to find derivative of both sides of our equation. So 1 is equal to t dt to dx. Now we multiply both sides by dx to reduce denominator. So we will have dx is equal, dx and dx we can reduce on the right side, so we have 2t dt. Now we can come back to our integral. So this is equal integral of x is t squared. So we have t squared and we have power 1/2 over x. Again we have, so t squared minus 1, and dx is 2t dt. So this is equal 2 and 2 we can reduce, and in numerator we will have only t times this t, so it will be t squared. 2 I will put before integral symbol, so we have over t squared minus 1 with respect to t. So this is equal, because in numerator and denominator we have the same degree, t to second power and t to second power, so we can use long division to rewrite our rational fraction, or we can rewrite that this is equal to times integral of t squared minus 1 we can put in numerator, and because we don't have this negative 1 before here, so I will put plus 1 over t squared minus 1 with respect to t. So this is equal, we have 2 integral of, and we can rewrite this rational fraction to two fraction, will be t minus 1 over t squared minus 1 plus 1 over t squared minus 1 with respect t. So this is equal, t squared we can reduce, and we have 2 times integral of 1 plus 1 over t squared minus 1 with respect to t. So this is equal, we have integral of sum, so we can rewrite to sum of integrals. So it will be 2 times integral of 1 will be with respect to t will be t, plus we have integral 1 over t squared minus 1. We can factorize, it will be t minus 1 times t plus 1 with respect to t. So this is equal. Now we will rewrite our rational fraction 1 over, we have t minus 1 times t plus 1 to sum of partial fractions. So this is identically equal to a over t minus 1 plus b over t plus 1. Next, to reduce this fraction, we will multiply both sides by t minus 1 times t plus 1. So on the left side, this denominator will reduce, and we will have only 1 is identically equal to a times t plus 1, because t minus 1 will reduce, so we have to multiply every fraction by this whole expression. And we have b times t minus 1. So now to find a and b, we will do substitution. For t equals negative 1 on the right side, first expression will reduce to 0. So on the left side we have 1. To have to rewrite, this is equal b times, and t we will substitute by negative 1 minus 1. So we have that 1 is equal b times negative 2. So we can write this is negative 2 times b. Now we will divide both sides by negative 2, and we have that b is equal negative 1/2. Next, we need to find a, so we will substitute t by 1 now. So we will have on the left side will be 1 and will be equal a times 1 plus 1 The second expression will reduce because will be 1 minus 1 is 0, 0 times b will be 0. So we have 1 is equal to a. I will divide both sides by 2. So we have that a is equal 1/2. Now we can rewrite our integral. Let me copy this whole expression first. We have 2 and in brackets we have t plus integral of, and we will have a is 1/2 over t minus 1 plus b is equal negative 1/2 over t plus 1, and we have integral with respect to t. So this is equal, we have close the brackets, we have to. When we have integral of sum, so this is equal sum of integrals. So we have 2 and we have t plus integral of 1/2 over t minus 1. So 1/2 we can put before integral, and we will have 1 over t minus 1 with respect to t. Negative and positive give me negative. 1/2 I will put before integral, and will be 1 over t plus 1 with respect to t, close brackets. So this is equal 2, and in brackets we have t plus 1/2 integral of 1 over t minus 1 is equal natural logarithm of absolute value of expression which is in denominator. Why? Because we have in numerator derivative of denominator. So we have natural logarithm of absolute value of t minus 1, and we have minus 1/2. The same situation is in the second integral. In numerator we have derivative of denominator, so we have natural logarithm of absolute value of t plus 1, and we have to add constant. I will put this at the end because when we multiply by 2 it still will be constant, plus c. So now we can do multiplication. We can multiply every expression by 2. And what else? We will do substitution because we have t here, but at the beginning we have x's. We should solve integral with respect to x. So now we have to come back to this substitution. We have x is equal t squared, so t is equal square root of x. So we will have 2 times t, so it will be 2 times square root of x plus 2 times 1/2 will reduce, and we will have natural logarithm of absolute value of square root of x minus 1, and again 2 times 1/2 will reduce, so we have only negative sign. Natural logarithm of absolute value square root of x plus 1 plus constant c. This is equal to square root of x plus, and now we use property of logarithm. We have the same base, so we can put that this is equal natural logarithm of absolute value of square root of x minus 1 over square root of x plus 1 plus constant c. This is my solution. Because we have 6 root of x to 5th power, so x must be greater than 0, because we cannot have 0 in the denominator. That's why I don't put here x is greater than or equals 0. Next, I will rewrite our cube root and 6 root to power form. So this is equal integral of x to power 1/3 with respect to x. We have integral over x plus we have 6 root of x to 5th power, so it will be x to 5th power to power 1 over 6. So this is equal integral of x to power 1/3 dx over x plus x to power 5 over 6. Now we will do substitution method. we will put that x is equal t to power 6. Why to 6? Because we need to check denominator of our exponent. We have 3 and 6. The common denominator is 6. That's why I put t to power 6. Now we have to find derivative of both sides with respect to x. So we have 1 is equal 6 t to power 5 d t to dx. Now we multiply both sides by dx. So we have that dx is equal 6t to 5th power dt. Now we will come back to our integral. This is equal integral of x is t to 6 power, and we have to power 1/3 over x is t to 6 power, and we have plus x is t to 6 power, and we have to power 5 over 6. dx is equal 6t to power 5th dt. So this is equal. Now we see that we can reduce denominator with 6, so will be 2, and 6 in denominator will reduce. So we have integral of will be only t square. 6 I will put before integral symbol. So we have times t to 5th power dt over t to 6th power plus t to 5th power. So this is equal. We can rewrite 6 integral, and I will rewrite our numerator t square times t to 5th power dt. Why I didn't do multiplication? Because I can factorize t to 5th power in denominator, and we will have t plus 1. Now we can reduce t to 5th power, and we have 6 integral of t square over t plus 1 dt. Because we have in numerator t to 2nd power and in denominator t to 1st power, so we will do long division. We have to divide t square by t plus 1. T square divided by t is t. Now we have to do multiplication. T times t is t square. T times 1 is positive t. Now we have to subtract. So we have t square minus t square is 0. Because we don't have here anything, it means we have 0. 0 minus t is minus t. So now negative t divided by t is negative 1. Negative 1 times t is negative t. And negative times positive will be negative 1. Again, we have to subtraction. So we have negative t. Negative and negative give me positive. Negative t plus t is equal 0. And we don't have here anything. So it's 0. Minus and minus give me plus, so will be 1. 0 plus 1 is 1. So we can rewrite our integral to form 6 integral of, and will be t minus 1. We have to copy what we got, and we have 1 positive, so we have to put 1 over t plus 1 dt, of course. So this is equal integral of sum or difference is equal sum and difference of integrals. So we have 6, and in brackets we will have integral of t with respect to t minus integral of 1 with respect to t plus integral of 1 over t plus 1 with respect to t. So this is equal 6 times integral of t is t squared over 2 minus integral of 1 with respect to t is t plus, and we have in numerator derivative of denominator, so we have to put that this is equal natural logarithm of absolute value of t plus 1. At the end I will put constant, because when we add constants and when we multiply by 6 we will still have constant. I will write this formula which I use for this integral. We have in numerator f prime of t over f of t with respect to t is equal natural logarithm of absolute value of f of t plus constant. Now we have to come back to our substitution. We have that x is equal t to 6 power. So let me write this here. We have x is equal t to 6 power. It means that t is equal 6 root of x. So now we will substitute our t's. So we have 6 times, in brackets we will have t squared, so it will be 6 root of x to second power over 2 minus 6 root of x plus natural logarithm of absolute value of 6 root of x plus 1 plus constant c. This is my solution. Because in denominator we have square root of x minus 5 and x minus 6, x minus 5 must be greater than or equal 0 and x minus 6 must be greater than or equal 0, because we calculate square root of positive or equal 0 values only. So we have that x must be greater than or equals 6. So now first I will rewrite our integral. We have dx over square root of x minus 5 plus square root of x minus 6. I will multiply numerator and denominator by the same expression with different signs. So it will be square root of x minus 5 minus square root of x minus 6. Numerator and denominator. In denominator we will use formula that a minus b times a plus b is equal a square minus b square. So we will have in numerator, we have to copy this whole expression, so it will be square root of x minus 5 minus square root of x minus 6, and I will put at the end dx. And now when we multiply this expression by this, we will have square root of x minus 5 to second power. So let me write this square root of x minus 5 to second power minus square root of x minus 6 to second power. So this is equal integral of numerator. We have to rewrite x minus 5 minus x minus 6 over square root we reduce with square, and we will have x minus 5 minus, before this whole expression we have negative sign, so we need to change the sign, so it will be negative x, negative and negative give me positive 6 dx. So this is equal x and x, positive and negative we can reduce, and we have integral of square root of x minus 5 minus square root of x minus 6 over negative 5 and positive 6 is 1. So we have integral of square root of x minus 5 minus square root of x minus 6 with respect to x. We have integral of difference, so this is equal difference of integrals. So this is equal integral of square root of x minus 5 with respect to x minus integral of square root of x minus 6 with respect to x. Now to solve these integrals we will use substitution method. Let me put that x minus 5 is equal t. So now we have to find derivative of both sides with respect to x. So will be 1 is equal dt to dx. We'll multiply both sides by dx. So we will have dx is equal dt. And to second integral we will use substitution that x minus 6 is equal u. So derivative of both sides with respect to x will be 1 is equal du over dx. Now we multiply both sides by dx, so we have that dx is equal du. This is substitution to first integral, and this is to the second integral. This is our second and first integral. So we have integral of x minus 5 is t. We have square root, so we can change to power form, will be 1/2. dx is dt minus, and we have integral x minus 6 is u for the second integral, and we have square root, so we have to power 1/2. dx is du. So this is equal. We have to find integral of power function. So this is equal t to power 1/2 plus 1 over 1/2 plus 1 is 3 over 2 plus constant c1 we can put minus integral of power function again. So it will be u to power 1/2 plus 1 over 1/2 plus 1 is 3 over 2 plus constant c2. So this is equal 3 over 2 we have, so it will be 2 over 3 times t to power 3 over 2. And next I will put this expression, so it will be 2 over 3 times u to power 3 over 2, constant plus constant, so we can put c. So this is equal. Now we have to come back to our substitution. So this is equal, and we can factorize 2 over 3. In brackets we will have t is x minus 5, and we have power 3 over 2 minus u is x minus 6, and we have power the same like before, 3 over 2 close brackets plus c. Because at the beginning we have square root, so we come back to square root now. So this is equal 2 over 3, and in brackets we will have square root of x minus 5 is to third power minus, and we have square root of x minus 6 to third power plus constant c. This is my solution. We have integral of irrational functions. So first we will change cube root and square root to power form. So this is equal integral of x dx over, we have x plus 1 will be to power 1/3 minus x plus 1 to power 1/2. Next we will use substitution method, but we have to check denominator of our exponent is 3 and 2, so the common denominator is 6. So we will substitute x plus 1 by t to 6 power. Because we need x2, so from this equation we have x is equal t to power 6 minus 1. And now we have to come back to our substitution. We have to find derivative of both sides with respect to x. So it will be 1 is equal 6t to 5th power dt to dx. We will multiply both sides by dx. So we have dx is equal 6t to 5th power dt. Now we can rewrite our integral. And we will have integral of x is t to 6 power minus 1. Dx is 6 t to 5th power dt over, and we have x plus 1, so we have t to 6 power, and we have power 1/3, minus, again, x plus 1 is t to 6 power, and we have to power 1 over 2. So this is equal. We can reduce 3 and 6 will be 2, and 2 with 6 will be 3. So now this is equal. We have integral of 6. I will put before integral symbol. So we have now t to 6 minus 1 times t to 5th power dt over will be t square minus t cube. So this is equal. We can factorize t square in the numerator. So 6 integral of t to power 6 minus 1 times t to 5th power dt over t squared. So it will be 1 minus t in the numerator. So this is equal. We can reduce t squared. So it will be t 5 minus 2 is 3. So we can rewrite that this is equal 6 integral, and we have t to power 6 minus 1 times t to power 3rd dt over 1 minus t. So this is equal. We can do multiplication in numerator. So we have 6 integral of will be t to 6 times t to 3rd power. We have the same x base, so we have to copy and add exponents. So it will be 6 plus 3 is 9 minus t cube over, and we have 1 minus t dt, because in numerator we have degree 9 and in denominator we have first t to 1st power. So now we have to do long division. We have to divide t to 9th power minus t cube by, we have 1 minus negative t, so I can change. I will put first negative t plus 1. So this is equal. T to 9 power divided by negative t will be negative t to 8 power. Now we have to do multiplication. Negative t to 8 times negative t will be positive t to 9th power, and negative t to 8 times positive 1, so it will be negative t to power 8. Now we have to subtract. So we have like t to 9 minus t to 9, so this is equal 0. And next we have here t to 8 power and t to 3rd. So first we have to put the highest power. Negative and negative give me positive t to 8, and we have negative t cube. Now we have to divide t to power 8 by negative t, so it's negative t to 7 power. Negative t to 7 times negative t is positive t to 8 power, and negative times positive will be negative t to 7. Subtract. So t to 8 will reduce, and we have, again we have to put first the highest power, so it will be t to 7, because negative and negative give me positive, and we have negative t to third. Again, we have to divide by negative t, so we have t to 6 power, negative t to 6 power. Now we have to do multiplication, so it will be positive t to 7. Negative times positive will be negative t to 6 power. Subtract. So this will reduce, and negative give me positive t to 6 power minus t to third power. Divide by negative 3, so it's negative t, so this is negative t to power fifth. Negative t to fifth power times negative t, so this is positive t to 6 power, and negative times positive will be negative t to fifth power. Subtraction, this first expression will cancel, and we have negative and negative, so will be positive t to fifth power minus t to third power. Divide by negative t, so it will be negative t to fourth power. Now we have to do multiplication, so will be positive t to fifth power, negative t to fourth power. Subtract. So this is equal t to 4 minus t to third. Divide by negative t, so it will be negative t to third power. Now multiplication, so it will be t to 4 minus t to third power. So we have to subtract, so this is equal 0. So now we can rewrite our integral to this form. So this is equal, will be 6 times integral of, and in parentheses we will put negative t to power 8, negative t to power 7, negative t to power 6, negative t to power 5th, negative t to power 4, and negative t to power 3rd with respect to t. We have integral of difference, so this is equal to difference of integrals. And I will put negative sign before integral symbol. So we have negative 6. So now we will have only positive values in parentheses, and we will use integral of power function formula. So in parentheses we will have integral of t to 8 power, so it will be t to 9 power over 9 plus t to 8 power over 8 plus t to 7 power over 7 plus t to 6 power over 6 plus t to 5th power over 5 plus t to 4th power over 4 plus constant c we can write. So this is equal. Now we have to come back to our substitution. We have that x plus 1 is equal t to 6 power. It means that t is equal 6 root of x plus 1. From this equation we have this. So we will substitute t's now. So this is equal negative 6, and in parentheses we will have 6 root of x plus 1 to power 9 over 9 plus 6 root of x plus 1 to power 8 over 8 plus 6 root of x plus 1 to power 7 over 7 plus, and we will have 6 root of x plus 1 to power 6 over 6 plus, now we have 6 root of x plus 1 to power fifth over 5 plus 6 root of x plus 1 to power 4 over 4 plus constant c. So this is equal. We can change this to power form to reduce exponents, so will be, and we can, what else we can do? We can do multiplication. I'll put negative sign before this whole expression, and 6 times 9 we can reduce, so will be 2 over 3, and we will have x plus 1 to power 9 over 6, so will be 3 over 2 plus, next 6 times 8, so will be, when we divide by 2, so will be 3 over 4 will be x plus 1, and to power 4 over 3, because we will have 8 over 6, so when we reduce by 2 will be 4 over 3 plus, and now will be 6 over 7. We multiply every expression by 6, negative sign I put before parentheses, and we have x plus 1 to power 7 over 6 plus, and we have 6 root and power 6, and we have times 6, so 6 and 6 will reduce, so we will have plus, and will be x plus 1, we can put in parentheses, plus will be 6 over 5 x plus 1 to power 5 over 6 plus 6 over 4, so will be 3 over 2 times x plus 1 to power 2 over 3 plus constant c. This is my solution. We have integral of irrational function. So first I will change square root and cube root to power form. So this is equal integral of, in numerator we have dx over x plus 1 to power 1 half plus x plus 1 to power 1/3. Now we will do substitution method. Because we have exponent 1/2 and 1/3, the common denominator for 2 and 3 is 6. That's why I will substitute x plus 1 is t to power 6. I always have to have here the common denominator of this exponent. So now from this equation we know that t is equal 6 root of x plus 1. And now to do substitution we need to find dt. So we have to find the derivative of both sides with respect to x. So will be 1 is equal 6t to 5th power dt to dx. We'll multiply both sides by dx. So we have dx is equal 6t to 5th power dt. Now we come back to our integral. And we will have that this is equal integral of dx is 6t to 5th power dt. And in denominator we will have x plus 1, so it's t to 6th power. We have to power 1/2 plus, and again x plus 1 is t to 6th power to power 1/3. Now we see why I put t to 6th power. 6 and 2 we can reduce, and we have 3, and 6 and 3 will be 2. So this is equal integral of 6t to 5th power dt over t cube plus t square. Now we can factorize t square in the numerator and we can put 6 before integral symbol. So we have 6 integral of t to 5th power dt over t square. So will be t plus 1 in parentheses. Now we can reduce t square and we will have t to 3rd power in numerator. So we can rewrite our integral. We have 6 integral of t cube dt over t plus 1. Because in numerator we have t to 3rd power and in denominator we have t to 1st power. So now we will do long division. We have to divide t 3rd power by t plus 1. So will be t square times t is t cube, t square times 1 is t square. Now we have to do subtraction. So we have t to cube minus t cube, so this is equal 0. And we have negative t square, divide now by t will be negative t. Negative t times t will be negative t square, and negative t times 1 is negative t. So this is equal, we have to do subtraction. So will be 0 and negative give me positive t. Positive t divided by t is 1. 1 times t is t. 1 times 1 is 1. Subtraction, so t minus t is 0 and we have negative 1 only. So we can rewrite our integral to form 6 integral of, we got t square minus t plus 1 and we have plus negative 1 over t plus 1, so will be positive and negative give me negative 1 over t plus 1. With respect to t we have integral. So this is equal, we have to copy 6 and we have integral of t square with respect to t, so this is equal, in brackets we will put t to 3rd power over 3 minus integral of t, so this is t square over 2 and we have integral of 1 is t minus integral of 1 over t plus 1. In numerator we have derivative of denominator, so it will be natural logarithm of absolute value of t plus 1 plus constant c. Now we can do multiplication, so this is equal 6 times 1/3, so will be 2 t cube minus 6 times 1 over 2, so will be 3 t square plus 6t minus 6 natural logarithm of absolute value of t plus 1 plus constant c. Now we have to do substitution. T is equal 6 root of x plus 1. So we will have 2 times and we will put for t 6 root of x plus 1. We have to 3rd power, so we can put like this, minus 3 and t is 6 root of x plus 1 and we have to put to 2nd power and we have plus 6 times 6 root of x plus 1 minus 6 natural logarithm of absolute value of 6 root of x plus 1 plus 1 plus constant c. We can rewrite this, that this is equal to, and we have 6 root and we have x plus 1 to 3rd power. So it will be, let me rewrite this to power form, x plus 1 3 over 6 minus 3x plus 1 to power 2 over 6 plus 6 root of x plus 1 minus 6 natural logarithm of absolute value of 6 root of x plus 1 plus 1 plus constant c. We can reduce numerator and denominator, so it will be 1 over 2 and will be 1 over 3. So we have 2 times x plus 1 to power 1 half minus 3 times x plus 1 to power 1/3 plus, and we have 6 times 6 root of x plus 1 minus 6 natural logarithm of absolute value of 6 root of x plus 1 plus 1 plus c. Can change this first two expression to roots. So this is equal to 2 times square root of x plus 1 minus 3 times cube root of x plus 1, and we have plus 6 times 6 root of x plus 1 minus 6 natural logarithm of absolute value of 6 root of x plus 1 plus 1. Of course, close brackets plus constant c. So this is my solution. We have integral of irrational function. So first I will change square root to power form. So this is equal integral of, we have t minus 2 over t minus 1 to power 1 half times dt over t minus 2 to second power. Now we will substitute t minus 2 over t minus 1, that this is equal u square, because we have exponent 1 half. So now we need to find t from this equation. So I will multiply both sides by t minus 1. So this denominator will reduce, and we will have t minus 2 is equal u square times t minus 1. Now we'll do multiplication on the right side. So we have t minus 2 is equal t u square minus u square. Now I will move expression with t's to the left side. So we will have t minus t u square is equal, I will move negative 2 to the right, so it will be 2 minus u square. T we can factorize, so we have 1 minus u square is equal to minus u square. Now we will divide both sides by 1 minus u square. We can reduce now, and we have that t is equal to minus u square over 1 minus u square. Now we have to find derivative of both sides of our equation with respect to t. So we will have 1 is equal, and derivative, we have quotient here, so in denominator we will have 1 minus u square to second power, and in numerator first we have to find derivative of numerator, so it will be negative 2u times denominator is 1 minus u square minus, now we have to copy numerator, so it's 2 minus u square times derivative of denominator is negative 2u du to t. So we have that one is equal. Denominator we have to copy. And we have to do multiplications. So it will be negative 2u plus 2u cube minus and minus we can reduce to positive. So will be 4u minus 2u cube du to dt, negative 2u cube and positive we can reduce. So we have, of course, we have 2 times 2, so it's positive here. So now I will multiply both sides by dt. So we have dt is equal 2u over 1 minus u square to second power du. We have dt, we have this whole expression equal u squares. So now we will find t minus 2 to second power. Let me copy this. We have t minus 2 to second power. We have that t is equal 2 minus u square over 1 minus u square. And we have minus 2, everything to second power. To subtract these two expressions, we need to have common denominator. So this is equal 1 minus u square we will have in denominator and will be 2 minus u square minus will be 2 times 1 minus u square. Everything to second power. So this is equal, in parentheses we will have 2 minus u square minus 2 plus 2u square over 1 minus u square. 2 and negative 2 we can reduce to second power we have. So this is equal u square over 1 minus u square to second power. So now we can come back to our integral because we have t minus 2 to second power in denominator. It means when we will do substitution, we have to flip this fraction. Let me put this here. So we have that our integral is equal t minus 2 over t minus 1 is u square, and we have to set 1 power 1/2 dt is equal to this expression. So we have 2u, we can write du, 1 minus u square to second power, and like I said, we have to flip this fraction. So we will have 1 minus u to second power over u square, everything to second power. So this is equal 2 and 2 we can reduce, and we have integral of 2 we can put before integral symbol. U times u will be u square over we have 1 minus u square to second power, and we can rewrite this whole expression that this is 1 minus u square to second power over u square to second power. So we can reduce this whole expression and square with numerator u square. So we have that I forgot we have to put of course du at the end. So this is equal, we have 2 integral of we have in denominator u square only, so 1 over u square, we can rewrite that this is u to power negative 2 with respect to u, so this is equal to u to power negative 1 over negative 1 plus constant c. As I'll just use integral of power function formula, so this is equal positive times negative is negative 2, and we have u to negative 1 power plus constant c. U is equal square root of t minus 2 over t minus 1. Let me write this here, that u is equal square root of t minus 2 over t minus 1. So we have that this is equal negative 2, and because we have the two negative 1 powers, so it means we have to flip this expression which we have here. We have t minus 2 over t minus 1, so let me write this first. We have square root of t minus 2 over t minus 1, everything to power negative 1. So this is equal, plus constant c of course, negative 2, and we will have to flip expression which is under square root. So will be square root of t minus 1 over t minus 2. Plus constant c. This is my solution. We have integral of irrational function. First, I will rewrite our denominator. We have integral of dx over square root of 1 minus 81x squared. I can rewrite that this is 9x to second power. Now I will use substitution method. I will substitute 9x by t. We have to find derivative of both sides with respect to x, so this is equal 9 is equal dt to dx. So we have to multiply both sides by dx, so we have 9 dx is equal dt. Because we have only dx here, so I will divide both sides by 9. 9 and 9 we can reduce, and we have that dx is equal 1 over 9 dt. Now we can substitute, so we have integral of dx is 1 over 9 dt over square root of 1 minus will be t to second power, because we have 9x to second power. So this is equal 1 over 9 we can take before integral symbol, and we have dt over square root of 1 minus t squared. This is equal arc sine, so we have copy 1 over 9 arc sine of t plus constant c. Now we have to come back to our substitution, so we have 1 over 9 arc sine of 9x plus constant c. This is my solution. We have integral of irrational function. So first, because we cannot have 0 in denominator, let's check our quadratic function. We have 5x plus 3x plus 2. So we need to calculate delta. Delta is equal b squared minus 4ac. B is coefficient before x, so this is equal 3. C is constant 2, and a is coefficient before x squared, so we have 5. So delta will be b squared, so it's 9 minus 4 times 5 times 2. So this is equal 9 minus 20 times 2 is 4. So this is equal negative 31. So delta is less than 0. It means we don't have real solutions. So everything is called okay. Expression under square root is always positive because we have coefficient before x squared positive. So it means our parabola is open up and we don't have roots because delta is less than 0. So we have only positive values. So everything is okay. Next, we see that we have in numerator derivative of expression which is under square root. Let me write this. When we take derivative of 5x squared plus 3x plus 2, it will be 10x plus 3. Exactly the same expression which we have in numerator. So let me remind you, when we have derivative of square root, let me write that this is f of x expression, derivative, this is equal f prime of x over 2 square root of f of x. I just use formula for derivative of square root. If you don't remember this formula, you can always rewrite square root to power form is to power 1/2, and derivative of this expression f of x to power 1/2 derivative, we have derivative of power function, so we have 1/2 times f of x to power 1/2 minus 1, so it's to negative 1/2 times derivative of f of x. So this is equal, we have to put this whole expression to denominator because we have negative sign, and 1/2, so it will be square root of f of x. 2 we have to rewrite in denominator, and in numerator we have f prime of x. You see, it's exactly the same what we have here. Derivative of square root of x is equal this. So we see that we have in numerator derivative of denominator exactly the same like we have here. We don't have only this 2 here. So we need to multiply this square root of f of x by 2. So let me write this, that integral of f prime of x over square root of x, square root of f of x, we have exactly the same like in our expression. In numerator we have derivative of expression which is under square root with respect to x. So this is equal 2 times square root of f of x plus constant. Because we don't have here this 2, that's why I have to multiply by 2 square root of f of x. So now our integral of 10x plus 3 over square root of 5x squared plus 3x plus 2 dx is equal 2 times square root of expression with under square root 5x squared plus 3x plus 2 plus constant c. This is my solution. Because in numerator we have x to first power, and in denominator we have square root and we have x squared, so we need to have in numerator derivative of expression which is under square root. So first let's calculate this derivative. We have 2 plus x minus x squared derivative. This is equal 1 minus 2x. So now we will divide our numerator by derivative of expression which we have in denominator under square root. So we will have to divide 6x plus 5 by 1 minus 2x. So this is equal, we have to divide 6x by negative 2x, so it's negative 3. Negative 3 times negative 2x is positive 6x. Negative 3 times 1 is negative 3. Now we have to subtract. So we have 5 plus 3 is 8. So now we can rewrite our numerator to form, let me copy our integral. Denominator stay the same. We have 2 plus x minus x squared. And in numerator, we have negative 3 times 1 minus 2x plus, what we get here, plus 8, our reminder. So this is with respect to x integral. Now we can rewrite our integral to two integrals. It will be negative 3 times 1 minus 2x over square root of 2 plus x minus x squared, and will be with respect to x plus integral 8 over square root of 2 plus x minus x squared with respect to x. So this is equal, first negative 3 we can put before integral, so we have negative 3 times integral of 1 minus 2x over square root of 2 plus x minus x squared with respect to x, and 8 we can take before integral 2, so it will be 1 over square root of 2 plus x minus x squared with respect to x. Now in first integral, in numerator we have derivative of expression which is under square root. So we can use formula that this is equal. Let me remind you this formula. When we have integral of f prime of x over square root of f of x with respect to x, this is equal to square root of f of x plus constant c. So we will have negative 3 times 2 times square root of 2 plus x minus x squared plus constant c1 we can write plus 8 times, and we have integral of 1 over, because we have under square root negative x to second power, so we have to rewrite our integral to form 1 over square root of 1 minus u square with respect to u. This is equal arc sine of u plus constant. To get this form, we have to complete square. We have under square root expression 2 plus x minus x squared. So this is equal, because we have negative sign before x squared, so we can put this before parentheses, and we will have x minus 1/2, because we have only x here, to second power, and when we take x minus 1/2 to second power, it will be x negative x squared, and next will be positive x, and we will have negative 1/4. We have only here 2. So we need to have here at the beginning 2 and 1/4, because when we subtract 1/4 will be only 2. 2 and 1/4 we will change to fraction, so it will be 9/4. Now we can rewrite our square root to form 9/4 minus x minus 1/2 to second power with respect to x. Now we will substitute x minus 1/2 by, because we need to have here 1 like in this formula, so we will substitute by square root of 9/4 t. So now we have to find derivative of both sides of our equation. So it will be 1 is equal 3/2 dt to dx. We will multiply both sides by dx. So we have dx is equal 3/2 dt. So now we can rewrite our integral to form, let me copy the beginning, 3 times 2 is 6, square root of 2 plus x minus x squared plus c1 plus 8, and we have integral of 1. For dx we will put 3/2 dt and we have square root of 9/4 minus x minus 1/2 is equal square root of 9/4 t. We have to second power. So now this is equal 6 square root of 2 plus x minus x squared plus c1 plus 8, and we have integral 3/2 we can put before integral symbol, and we have 1/, square root of 9/4 minus square root of 9/4 to second power, so it will be 9/4 t square dt. So this is equal, we can factorize 9/4 in denominator under square root, so this is equal 6 times 2 plus x minus x squared plus c1. 2 we can reduce with 4, 8 will be 4, so we have plus 12, and we have integral of 1 square root of 9/4 times 1 minus t squared dt. So this is equal 6 square root of 2 plus x minus x squared plus c1 plus 12, and we have integral of square root of 9/4 is 3/2, and we have square root of 1 minus t squared in denominator. In numerator we have 1 dt. So this is equal, we have 6 square root of 2 plus x minus x squared plus c1 plus 12, and we can take this fraction before integral, and we will flip this because we have this fraction in the numerator, so it will be times 2/3, and I forgot that we have negative 3 here, so I have to put this negative sign before this first expression, And next we have integral of 1 over square root of 1 minus t squared dt. So this is equal, we can reduce 3 and 12 will be 4. So we have negative 6 square root of 2 plus x minus x squared plus, we will put constant at the end, so we have plus 8 integral of 1 over square root of 1 minus t squared is equal arc sine of t in our example, so it will be times arc sine of t plus constant c we can put. So this is equal. Now we have to come back to our substitution. T is equal, we have to calculate from this equation. We have x minus 1/2 is equal square root of 9 over 4t. So now we will divide both sides by square root of 9 over 4. So this we can reduce, and we have that t is equal x minus 1/2 over 3 over 2. So we can flip this expression, this fraction, so it will be 2 over 3 times x minus 1/2. So we can multiply by 2. So t is equal 2x minus 1 over 3. So we will have negative 6 square root of 2 plus x minus x squared plus 8 arc sine of 2x minus 1 over 3 plus constant c. This is my solution. We have integral of irrational function. We know that we cannot have 0 in denominator, and under square root we have to have expression greater than or equal 0, so x plus 5 must be greater than or equal 0. So we have from the second inequality that x must be greater than or equals negative 5, and because x must be different than 0, so we have interval from negative 5 to positive infinity, and we have to subtract 0. So now first I will rewrite our square root to power form. So this is equal integral of x plus 5 to power 1/2 over x with respect to x. Next I will substitute x plus 5 by t squared. So now we have to find derivative of both sides with respect to x. So we have 1 is equal 2t dt to dx. So now we multiply both sides by dx. So we have dx is equal to t dt. Now we will have to find x, because in the numerator we have only x. From this equation we have that x is equal t squared minus 5. So we will rewrite our integral, and we will have t to second power to power 1/2. I substitute x plus 5 by t squared over x is t squared minus 5, and we have dx is 2t dt. Next we can reduce 2 and 2. So now we will put 2 before integral symbol. So we have only t times t will be t squared in numerator over t squared minus 5 in denominator dt. So this is equal, because we have the same degree in numerator and in denominator, so first I will rewrite our integral. I will write our numerator to form t squared minus 5, because t squared minus 5 I have in denominator, plus 5. I have to add this 5 because we don't have this any constant. So negative 5 plus 5 is 0, so everything is okay. We have only t squared. T squared minus 5 in the denominator dt. So now we can rewrite our expression to fraction. We will have integral of t squared minus 5 over t squared minus 5 plus 5 over t squared minus 5 with respect to t. So this is equal. Integral of sum is equal sum of integrals. So we have 2, and in brackets we will have integral of 1 with respect to t, because t squared over t squared minus 5 we can reduce, and we have plus integral of 5 we can take before integrals, so we have 1 over t squared minus 5 dt. So this is equal. We have 2 times integral of 1 with respect to t is t plus 5, and we can rewrite our denominator to form t minus square root of 5 times t plus square root of 5. 1 in numerator we have dt. So first I will rewrite our rational fraction to sum of partial fractions. Let me copy this expression. We have 1 over t minus square root of 5 times t plus square root of 5. So this is identically equal to a over t minus square root of 5 plus b over t plus square root of 5. Now we need to find a and b. So first I will multiply both sides by t minus square root of 5 times t plus square root of 5 to reduce denominators. So on the left side we will have only 1 is identically equal to a, and we have to multiply every fraction by this whole expression. So t minus square root of 5 will reduce, and we will have only t plus square root of 5 times a plus, and we will have b times t minus square root of 5. Now to find a and b I will use substitution method. I will put first t is equal square root of 5. So on the left side we have always 1, so this is equal. When I put for t square root of 5, I will have a times square root of 5 plus square root of 5, and the second expression will be 0, because square root of 5 minus square root of 5 is 0, 0 times b is 0. So we have 1 is equal to square root of 5a. Next, I will divide both sides by 2 square root of 5. So this and this we can reduce, and we have that a is equal 1 over 2 square root of 5, because we don't like to have square root in denominator. I will multiply numerator and denominator by square root of 5. So this is equal square root of 5 over 2 times 5 will be 10. Next, I will substitute t by negative square root of 5. So we will have on the left side is always 1 is equal. When I put negative square root of 5, first expression will reduce, and we will have b times negative square root of 5 minus square root of 5. So we have 1 is equal negative 2 square root of 5b. We will divide both sides by negative square root of 5. So we have this and this and that we can reduce, and we have that b is equal -1/2 square root of 5. Now we will multiply by square root of 5 numerator and denominator. So we have that b is equal negative square root of 5/10. Next, we can go to this partial fraction. We will substitute and b, and we can rewrite our integrand to sum of two partial fractions. So we have now to copy first part. So we have 2 times t plus 5. Integral will be a is equal square root of 5/10, and we have t minus square root of 5 in denominator, plus, and b is equal negative square root of 5/10 over t plus square root of 5. Integral with respect to t we have. This is equal. We have 2 times t plus 5. Integral of sum will be equal sum of integrals, and we can take constant before integral symbol. So we have 5 times square root of 5/10. Integral we have 1/t minus square root of 5 with respect to t. And we have negative and positive, so will be negative 5. We have to copy, and we have constant square root of 5/10, and we have integral of 1/t plus square root of 5 with respect to t. So now we have to close brackets. So this is equal 5. We can reduce with 10. Will be 2, and we have 2 in brackets t plus square root of 5/2. In numerator we have derivative of denominator, so our integral is equal natural logarithm of absolute value of t minus square root of 5 plus constant we will put at the end, minus, and we have square root of 5/2. Again, we have in numerator derivative of denominator, so this is equal natural logarithm of absolute value of t plus square root of 5. And at the end we will put plus constant c. So this is equal. We can do multiplication, and we will substitute t by square root of x plus 5, because x plus 5 is equal t square. So t is equal square root of x plus 5. So we will have 2 times square root of x plus 5. 2 times 2 in denominator we have, so will be only square root of 5. Natural logarithm of absolute value t is square root of x plus 5 minus square root of 5 minus, and 2 will cancel, so we will have square root of 5 natural logarithm of absolute value of square root of x plus 5 plus square root of 5 plus constant c. We can factorize square root of 5, and because we have the same base, we can use property of natural of logarithm, and we can rewrite this, that this is equal. First expression we will copy, and we will have plus square root of 5 times natural logarithm of absolute value of square root of x plus 5 minus square root of 5 over square root of x plus 5 plus square root of 5 plus constant c. This is my solution. We have integral of irrational functions. So first I will rewrite square root to power form. So this is equal integral of x to power 1/2 minus 1 over x to power 1/2 plus 1 with respect to x. I will put that x is equal t squared because I want to reduce this denominator of our exponent. So 1 is equal to t dt to dx. We'll multiply both sides by dx, so dx is equal to t dt. Now I will substitute. So we have integral of x is t squared and we have to power 1/2 minus 1 over t squared to power 1/2 plus 1. dx is 2t dt. So this is equal 2 and 2 we can reduce, the same in denominator will be. So we have 2 we can take before integral symbol. In numerator we will have t minus 1 over t plus 1 in denominator times t dt. So now I will multiply numerator by t. So we have 2 integral of t squared minus t over t plus 1 dt. Because in numerator we have t to second power and in denominator we have t to first power. So first I will do long division. We have t squared minus t. We will divide by t plus 1. So it will be t squared divided by t will be t times t is t squared. T times 1 is t. We have to subtract now. So this will reduce and negative t minus t will be negative 2t. Now we'll divide by t, so will be negative 2. Negative 2 times t will be negative 2t and negative 2 times 1 is negative 2. Now we have to again do subtraction. So we will have only 2. So now we can rewrite our integral to form. We have 2 integral of t minus 2 plus 2 over t plus 1 with respect to t. So this is equal. We have 2 times integral of t with respect to t minus integral of 2 dt plus integral of 2 over t plus 1 dt. So this is equal. We have to copy 2 and in brackets we will have integral of t is equal t squared over 2 minus 2 we have to put first, so we have integral of 1 is t with respect to t plus 2 we have to copy before integral, and now we will have in numerator only 1. In denominator we have t plus 1 with respect to t. So this is equal. We can do multiplication, so 2 and 2 will reduce and we will have t squared minus 4t plus 4. In numerator we have derivative of denominators, so this is equal natural logarithm of absolute value of t plus 1 plus constant c. So now we have to come back to our substitution. We have that x is equal t squared. So it means that t is equal square root of x. So we will substitute now t's by square root of x. So we have and t squared by x. So we have x minus 4 times square root of x plus 4 times natural logarithm of absolute value of square root of x plus 1 plus constant c. This is my solution. First, I will rewrite our fifth root to power form. So this is equal integral of dx over x to power 1 over 5 minus 2. Next, I will substitute x by u to power 5. Why? Because I want to reduce our denominator in our exponent. So now we have to find the derivative of both sides with respect to x. So it will be 1 is equal 5u to power 4 du to dx. Now we multiply both sides by dx, so we will have dx is equal 5u to 4th power du. So our integral will be now dx is 5u to power 4 du over, we have x is u to power 5th and everything to power 1 over 5 minus 2. So this is equal 5 we can take before integral symbol, so we have 5 integral in numerator u to 4th power du, and in denominator 5 and 5 will reduce and we will have u minus 2. So now we will do long division because we have in numerator u to power 4 and in denominator we have u to first power. So we have u to power 4 divided by u minus 2. So it will be u to third power. Now we have to do multiplication, will be u to fourth power minus 2u to third power. Now we have to subtract. So u to fourth power will reduce and we will have negative, and negative give me positive 2u cube. 2u cube divided by u, so will be plus 2u square. So now we have to do multiplication, so it will be 2u cube and minus 4u square. Have to subtract, so 2u cube will reduce and we have 4u square divided by u, so it will be plus 4u. So now we have to again do multiplication. 4u times negative 2 will be negative 8u. Now we have to subtract. First expression will reduce and we have positive 8u divided by u is 8. 8 times u is 8u. 8 times negative 2 is negative 16. So this is 16. So now we can rewrite our integral and we will have 5 times integral of, have to copy what we got on the top, is u cube plus 2u square plus 4u plus 8, and we have plus 16 over u minus 2 du. So this is equal. So now we can rewrite our integral. This is equal 5 we have to copy and we have integral of u cube. So this is u to 4th power over 4 plus 2 we have to copy, and integral of u square is u to third power over 3, plus 4 we have to rewrite, and we have u square over 2 plus integral of 8 we have, so 8 u we will have, of course we have here plus integral of 16 over u minus 2, so 16 I have to copy, and we have integral of 1 over u minus 2 du. So this is equal 5 times, and in brackets we will have u to fourth power over 4 plus, we can write 2/3 u cube plus 2 with 4 we can reduce, 2u square plus 8u plus 16, and integral of 1 over u minus 2 is natural logarithm of absolute value of u minus 2. Why? Because in numerator we have derivative of denominator plus constant c. We can write at the end. So this is equal. We have to come back to our substitution. X, u is equal. We have that x is u to fifth power. So u is equal fifth root of x. So we will have, we can do multiplication. We have times 1 over 4, so it will be 5 over 4 fifth root of x to fourth power plus 5 times 2 over 3 will be 10 over 3 fifth root of x to third power plus 2 times 5 is 10 fifth root of x to second power plus 5 times 8 is 40, u is equal fifth root of x, and we have plus 5 times 16 is 80, natural logarithm of absolute value of fifth root of x minus 2 plus constant c. This is my solution. First, I will substitute square root of x minus 1 by t square. Why by t square? Because we have square root of this whole expression. So we have square root of x minus 1 is equal t square. So square root of x is equal t square plus 1. I just move negative 1 to the right side. Now, because we have square root of x here, so to find x, I will take both sides to second power. So we have x is equal t square plus 1 to second power. So now we have to find derivative of both sides. Dx is equal to, in parentheses we have t square plus 1 times 2t dt. So now we can rewrite this, that dx is equal 4t t square plus 1 dt. So we will have integral dx is, we can do multiplication, 4t times t square is 4t cube, 4t times 1 is 4t, and over we have square root of x minus 1 is t square, so we have square root of t square dt, of course. So this is equal, We can factorize 4 in numerator, so we will take this 4 before integral symbol. So we will have now t cube plus t over square root of t squared is t dt. So this is equal 4 times integral, we will factorize t squared plus 1 over t. Now we can reduce t and t, so we have 4 integral of t squared plus 1 dt. So this is equal, integral of sum is equal sum of integrals. So we will have 4 and in brackets will be integral of t squared, so it's t cube over 3 and integral of 1 is t plus constant c. So this is equal 4 over 3 t cube plus 4t plus c. Now we have to come back to our substitution. We have that t squared is square root of x minus 1. It means that t is equal square root of x minus 1. So now we will substitute our t's. It will be 4 over 3 times, we will have square root of x minus 1 to third power, you can put in parentheses, to third power, plus 4 times square root of x minus 1 plus constant c. This is my solution. We have irrational functions, so first I will rewrite our cube root and 4 root to power form. So this is equal integral of dx over, we have x to 1/3 power minus x to 1 over 4 power. Now because we have x to 1/3 and x to 1 over 4 power, so I will substitute x by u to power 12. We have to always check the denominator of our exponents and choose the common denominator. For 3 and 4 will be 12. So now derivative of both sides we have to find, so will be dx is equal 12 u to power 11 du. So now we will substitute, we will have integral of dx is 12 u to power 11 du over, we have u to 12 power and to power 1/3. I substitute x by u to 12 power minus, and we have u to 12 power to power 1 over 4. This is equal 12 with 3 we can reduce, will be 4, and 12 with 4 will be 3. So we have we can take 12 before integral, so we have 12 integral of u to power 11 du over u to 4 power minus u to 3rd power. So this is equal 12 integral, and we have in numerator u to power 11 du over, and we can factorize u cube, and in parentheses we will have u minus 1. So this is equal, we can reduce u cube with 11 will be 11 minus 3 is 8. So we have 12 integrals of u to power 8 du over u minus 1. Because in numerator we have u to 8th power, and in denominator u to first power. So now we will do long division. So it will be u to 8th power. We will divide by u minus 1. So this is u to 8 divided by u is u to 7th power. Now we have to do multiplication. So it will be u to 8 minus u to 7th power. Now we have to subtract. So it will be u to 7th power divided by u. So this is u to 6th power. Now we have to do multiplication. And now we have to again subtract. So we have u to 6 divided by u is u to 5th power. Now again multiplication. So u to 6 and u to 5th times -1 is negative u to 5th. Again subtraction. So we have u to 5th divided by u is u to 4th power. And now multiplication, so will be u to 5th power minus u to 4th power, subtraction again. So we can reduce u to 5th power and we have plus u to 4th power divided by u is u to 3rd power. Now multiplication, so will be u to 4th power minus u to 3rd power, again subtraction. U to we will reduce and we have u to 3rd divided by u is u square times u is u cube times -1 negative u square, subtraction again. So u cube will reduce and we have u square divided by u is u times u is u square. U times -1 is negative u. So again subtraction and u square will reduce and we have u divided by u is 1 times u is u times -1 is -1, again subtraction. So we have negative and negative give me positive. So we can rewrite our integral to form this equal. We have to copy 12 and in brackets we will have integral of whatever we get here. This is u to 7th power plus u to 6th power plus u to 5th power plus u to 4th power plus u to 3rd power plus u square, of course, plus u plus 1 and plus we have 1. At the end we need to divide by u minus 1 and we have integral with respect to u. So this is equal integral of sum is equal sum of integrals. So we will calculate integral of u to 7th power is u to power 8 over 8 plus will be u to power 7 over 7 plus u to power 6 over 6 plus u to power 5th over 5 plus u to power 4 over 4 plus u to power 3rd over 2 plus u to power 2nd over, of course, over 3 we have here, over 2 plus integral of 1 is u and integral of 1 over u minus 1 is natural logarithm of absolute value of u minus 1 plus constant c. So this is equal. We have to substitute now u by x. x is equal u to 12 power. So u is equal 12 root of x. So now we will substitute u by 12 root of x. So we have 12, and in brackets we have 12 root of x to power 8 over 8 plus 12 root of x to power 7 over 7 plus 12 root of x to power 6 over 6 plus 12 root of x to power 5th over 5 plus 12 root of x to power 4 over 4 plus 12 root of x to third power over 3 plus 12 root of x to second power over 2 plus, and we have 12 root of x plus natural logarithm of absolute value of 12 root of x minus 1 plus constant c. So now we can change 12 root to power form to reduce exponent. So this is equal 12 we will rewrite, and in brackets we will have in numerator will be x to power 8 over 12 plus we have x to power 7 over 12 plus denominator we copy x to power 6 over 12 plus x to power 5th over 12 over 5 plus x to power 4 over 12 over 4 plus x to power 3 over 12 over 3 plus x to power 2 over 12 over 2 plus we have plus 12 root of x plus natural logarithm of absolute value of 12 root of x minus 1 plus constant c. We can reduce exponents, so this is equal, close brackets of course, we have 12 times, and we will have x to power, we can divide by 4, so it will be 2 over 3 over 8 plus x to power 7 over 12 over 7 plus x to power 1/2 over 6 plus x to power 5 over 12 over 5 plus x to power 1 over 3 over 4 plus x to power 1 over 4 over 3 plus x to power 1 over 6 over 2 plus 12 root of x plus natural logarithm of absolute value of 12 root of x minus 1. Close brackets plus c. This is my solution. First I will change our integrand to fraction. So we have integral of will be square root of 1 minus 9x squared over, we will put 1, and now I will multiply numerator and denominator by square root of 1 minus 9x squared over square root of 1 minus 9x squared. With respect to x, we have integral. So now we have square root of 1 minus 9x squared times square root of 1 minus 9x squared. It means we can write that this is equal integral of 1 minus 9x squared over square root of 1 minus 9x squared. Of course, whatever is under square root must be positive value. So x must belongs to interval from negative 1/3 to 1/3. Next, we can rewrite our integral to two integrals. Will be integral of 1 over square root of 1 minus 9x squared minus, with respect of course to x, I forgot to add here, and minus integral of 9x squared square root of 1 minus 9x squared with respect to x. Next, because we have here 1 minus 9x squared, we will have to do everything to get integral of 1 over square root of 1 minus u. We can write square with respect to u is equal arcsine of u plus constant c. So to get this expression, we will rewrite our first integral to form, let me write this, it will be 1 over square root of 1 minus, we can write 3x to second power dx minus, and we can take this 9 before integral, so we have 9 integral of x squared over square root of 1 minus 9x squared dx. Let me write this like this. So now this is equal. We can do substitution. We can put that 3x is equal u to first integral, so 3 dx will be equal du. We'll divide both sides by 3 because we need only dx. dx is equal 1/3 du. So now our first integral we can rewrite to form, we have 1 over square root of 1 minus u squared, and dx is 1/3 du minus, and we have to copy the second part, 9 integral of x squared over square root of 1 minus 9x squared dx. So this is equal, we have to copy first 1/3, and we know that 1 over square root of 1 minus u squared du is equal arcsine of u. In our example, u is equal 3x. We can come back to our substitution. Plus constant, of course, and we have minus 9 integral of x squared over square root of 1 minus 9x squared dx. To solve this part, first we will come back to our integral, and now we will solve this integral using formula for integration by parts. So let me rewrite this example. We have integral of square root of 1 minus 9 x squared dx. Because when we use integration by parts, we need two functions. We can put, this will be our one's function, and I will add 1. So we have 1 times the square root. So we have two functions. Let me remind you formula for integration by parts. We have integral of f of x times g prime of x with respect to x. This is equal f of x times g of x minus integral of g of x times f prime of x with respect to x. So let's put that our f function will be equal square root of 1 minus 9x squared. So I can change this to power form, so will be 1 minus 9x squared, and our g prime will be equal 1. So now we need to find f prime and g. F prime of x will be equal, of course I forgot to add power 1/2 because we have square root. So derivative of our expression will be 1/2 times 1 minus 9x squared will be to power 1/2 minus 1 will be to negative 1/2. And next we have to find derivative of expression which is inside parentheses. So will be negative 9 times 2, so will be 18x. And g of x is equal x. So now we can come back to our formula and rewrite our integral to form. First we have f times g, so it will be, we can come back to square root, so it will be square root of 1 minus 9x squared times g is x, I can put first. And next we have minus integral of g is equal x and f prime is equal, we have 1/2 and we have to negative power, so it means we have to take this expression to denominator, and because we have power 1/2, so it will be square root of 1 minus 9x squared, and in numerator we will have negative 18x. With respect, of course, to x we have integral. So this is equal, we can reduce 18 and 2, so it will be 9. And now we have to copy first part is x times square root of 1 minus 9x squared. Negative and negative give me positive, integral 9, and we have x times x. So 9 I can put before integral, and we have x squared over square root of 1 minus 9x squared dx. We got exactly the same expression which we have in the first solution. So now let me rewrite our two solutions. First was, let me copy our example, when we have integral of square root of 1 minus 9x squared dx, we solved this problem and we got that this is equal 1/3 arc sine of 3x. Of course we have to add constant. I will put this at the end, and we have minus 9 integral of x square over 1 square root of 1 minus 9x squared dx plus constant. And when we used integration by parts, the second method, we got that integral of 1 minus 9x squared dx is equal x square root of 1 minus 9x squared plus 9 integral of x squared over square root of 1 minus 9x squared dx. So now, when we add these two solutions, we see that our last integral will reduce because we have negative and positive 9. So we can add this together. And we will have 2 integral of square root of 1 minus 9x squared dx is equal, first we have 1/3 arc sine of 3x, and this part and this will reduce, and we will have plus x square root of 1 minus 9x squared. Of course, we have to add constant. And now, because we have here 2, so I will divide both sides by 2. So we have that integral of square root of 1 minus 9x squared dx is equal 1/2 times, and in brackets we will have 1/3 arc sine of 3x plus x times square root of 1 minus 9x squared plus constant c. This is my solution. We have integral of square roots. So first I will change this to power form. We have integral of e to power x plus 1 to power of 1/2 with respect to x. Next, I will do substitution. I will substitute e to power x plus 1 by t squared. So we will have to find derivative of both sides of our equation with respect to x. So we have e to power x is equal to t dt to dx. Now we multiply both sides by dx. So we have e to power x dx is equal to t dt. Because we have only dx here, so I will divide both sides by e to power x. So e to power x we can reduce, and we have that dx is equal to t and dt. Ex we will find from this equation is equal t squared minus 1. So we have over t squared minus 1. Now we can substitute. So our integral is equal e to power x plus 1 is t squared to power 1/2 dx is equal to t dt over t squared minus 1. So now 2 and 2 we can reduce. I will put 2 before integral symbol, and we have t squared over t squared minus 1 dt. Now I can rewrite our numerator. 2 we will copy. T squared, because we have in denominator t squared minus 1, and we have the same power t squared and t squared, so we can do long division, or you can rewrite this to t squared minus 1 plus 1 over t squared minus 1 dt. So this is equal to, we have to copy, and we have integral of t squared minus 1 over t squared minus 1 plus 1 over t squared minus 1 with respect to t. So this is equal We have integral of sum, so this is equal sum of integrals. T squared minus 1 we can reduce. And we have that this is equal to 2 times integral of 1 with respect to t plus integral of 1, and denominator we can rewrite that this is t minus 1 times t plus 1 dt. So this is equal, we have 2, and in brackets integral of 1 with respect to t is t, and we have plus. Now we can rewrite our integral, our integrand. We have rational fraction 1 over t minus 1 times t plus 1. So we will write that this is identically equal to a over t plus minus 1 plus b over t plus 1. Now we will multiply both sides by t minus 1 times t plus 1 to reduce this fraction, and we will have 1 is identically equal to a times t plus 1 plus b times t minus 1. Now we'll use substitution method to find a and b. So first I will put that t is equal 1. So on the left side we have constant 1. This is equal a will be 1 plus 1 is 2. 1 minus 1 is 0, so the second expression will reduce. So we have a is equal 1 over half. And when we put that t is equal negative 1, we will have 1 is equal, first expression will reduce, and we will have negative 2b. So b is equal negative 1 half. Now we can rewrite our integral to sum of these two partial fractions. A is equal 1 half over t minus 1, and we have plus b is negative 1 half over t plus 1 with respect to t. We have integral, so this is equal, we have to copy 2, and we have t plus constant we will take before integral, so we will have 1 half and integral of 1 over t minus 1 dt. Positive and negative give me negative, will be 1 half integral of 1 over t plus 1 dt. So this is equal to, and we have in brackets t plus 1 half. In numerator we have derivative of denominator, so integral will be equal natural logarithm of absolute value of t minus 1 minus 1 half, the same situation we have here, natural logarithm of absolute value of t plus 1 plus constant c we can write at the end. So this is equal, we can multiply by 2, and we can substitute t by, because t squared is equal e to power x plus 1, so we can write that t is equal square root of e to power x plus 1. So we will have 2 square root of e to power x plus 1 plus, when we multiply by 2, so this fraction will reduce, and we will have natural logarithm of absolute value of square root of e to power x plus 1 minus 1, and we will have minus 1 half will reduce because we multiply by 2, so it will be natural logarithm of absolute value of square root of e to power x plus 1 plus 1. So this is equal, because we have here difference of logarithm and we have the same base, so we can rewrite that this is equal, first expression we have to copy e to power x plus 1 plus will be natural logarithm of absolute value of square root of e to power x plus 1 minus 1 over square root of e to power x plus 1 plus 1 plus constant c. I forgot to add here. So this is my solution.